Okay, so this is a problem similar to the last one where we have an electron and it is entering two parallel plates. And notice that the parallel plates, the top one is negative and the bottom one is positive. And so the force on my electron is going to be down. So if I draw my free body diagram, I'm going to have a force down, force E. And so this question, it says if my electron starts off with a velocity of 3 times 10 to the 6th meters per second to the right, what will its velocity be as it leaves the parallel plates? So, so what we can do is we can say, okay, I can use the acceleration that we found in the last problem. So we'll give that as a given. So my acceleration is equal to 2.64 times 10 to the 14th meters per second squared. And then I have the charge, the mass, the length, and the velocity. And so I'm going to use, I know two things. I know the velocity when it leaves here is going to have an x component and a y component. So my x component is going to be the same. So my Vx final is going to equal my Vx initial, which is going to be equal to 3 times 10 to the 6th meters per second. And my Vy final is going to equal, I'm going to use the equation Vy final squared is equal to Vy initial squared plus 2AD. And this is going to be in the y direction. And I know that I have no horizontal velocity, or no vertical velocity here, so this is going to go to 0. And so my Vy final is going to equal the square root of 2 times AY times D. So plugging that in, I'll have 2 times 2.64 times 10 to the 4th meters per second times my distance is 0.2 meters square root. And so I haven't multiplied that out yet. So let's see. So I'm just using my calculator. And let's see. 2 times 2.64 e to the 14th. So this should be to the 14th here. Take the square root of that. And I get 102,76186 meters per second. So I'm going to rewrite that as y final is equal to 123. So 10.3 times 10 to the 6th meters per second. And now to find the magnitude and direction, I can say, okay, V final is equal to Vx final squared plus Vy final squared square root. So plugging that in, I'm going to have 3 times 10 to the 6th meters per second squared plus 10.3 times 10 to the 6th meters per second squared square root. So if I take my answer squared plus, so I wrote this wrong, this should be 2.264 times 10 to the 14th. No, that's not right either. Let's see, so I have 10, that's right, so this is the number I'm looking for, 10.3 times 10 to the 6th meters per second. So V final is equal to, let's see, so 3 e to the 6th squared plus 0.3 e to the 6th equals, and then square root of my answer. And I get 3 times 10 to the 6th. Doesn't seem quite right. I forgot to square something. So squared. And then I take the square root of that. So my final answer is 10.7 times 10 to the 6th meters per second. And if I want to find my angle, I can say tan theta. So I've got this component, which is 3 times 10 to the 6th meters per second, and this component, the down component, is 10.3 times 10 to the 6th, and that's a lot longer. Be a lot bigger like that. And so that's going to be my result, and so let's use this angle. So tan theta is equal to 10.3 times 10 to the 6th over 3 times 10 to the 6th. So my theta is going to equal, let's see, 10.3 divided by 3 because they have the same units, and then inverse tan, answer. So I get, let's see what mode I'm in. I'm in radians. Okay, so I can leave it in radians. So my theta is going to be 1.3 radians. And let's see, I can change that to degrees. So tan of delete. So 10.3 divided by 2, or divided by 3, is 73 degrees, 73.8 degrees. And so that's this angle here. And so that angle is really a negative, right? So I'm measuring from here and going down, so that's a negative angle.